All right, new problem. We're trying to find the antiderivatives of 4x squared over x to the fourth minus 16. So we've got a polynomial divided by a polynomial. We can do integration by using partial fractions. The degree of the top is smaller than the degree of the bottom, so we do not need to do any polynomial long division. So what we do need to do, though, is we need to factor the bottom. So if we got 4x squared all over x to the fourth minus 16, all right, well, the bottom can be factored as x squared minus 4 times x squared plus 4. And then we can keep going. We can factor x squared minus 4 as x minus 2 times x plus 2. Now x squared plus 4, we can't factor that. Sum of squares ain't gonna factor. At least not using real numbers. So, all right. So, we got the bottom factored. All right. So we're trying to do a partial fraction decomposition of 4x squared all over x squared plus 4 times x minus 2 times x plus 2. So we factored all the way. So what's going on this time? Well, this time we have an irreducible quadratic factor. It has degree 2 in it. So our method of guessing is going to need to change a little bit. So what we're going to do this time is we're going to guess that we can break up our fraction as ax plus b all over x squared plus 4. So if you have an irreducible quadratic factor, you got to guess that the numerator is linear. That right, you have a degree 1 polynomial. And then you're going to guess that you have c over x minus 2, and you're going to guess that you got d over x plus 2. And remember, I keep using the word guess, but this is guaranteed to work. Some guy proved that you can always do a partial fraction decomposition, and that if you make the correct guess, so to speak, it is guaranteed to work. So, okay. So what we got to do now is we got to multiply both sides by x squared plus 4, x minus 2, and x plus 2 to clear out all the fractions. So if we do that, if we multiply the left side by all the stuff in the denominator, all right, all of it will disappear. On the right side, x squared plus 4 will cross off with this x squared plus 4. You will be left with ax plus b times x minus 2 times x plus 2. Here, this x minus 2 will cross off with this x minus 2 when everything's being multiplied. You'll be left with c times x squared plus 4 times x plus 2. All right. Now, let's look at this guy. Okay, this x plus 2 will cross off with this x plus 2 if you multiply both sides by this thing. You'll be left with d times x squared plus 4 times x minus 2. All right, now this is a big old mess. So one way to do this problem would be to multiply all this stuff out, combine like terms, and use what I called option number 1 and solve a system of equations. Be a bit of a pain. Let's try to use the Heaviside method. So let's just start plugging in numbers for x. Okay, well, it looks like 2 is going to be a good number to plug in. If you plug in 2, this will become 0. And this last one will become 0. Looks like we'll be able to find c. So, okay, when x equals 2, well, what happens? Okay, when x equals 2, on the left side, we have 4 times 2 squared. On the right side, we have, let's see, if you plug in 2 here, you'll get 0. So that guy's going to disappear. if you plug in 2 here, you'll have c times 2 squared plus 4 times 2 plus 2. And over here, if you plug in 2, that'll make this 0, so that guy's gone. So we're left with, let's see, 4 times 4 is 16, equals 4 plus 4 is 8, times 4 is 32. Divide both sides by 32, and we get c is 1/2. Yay, we got c now. So, okay. All right, now what's another good number to plug in? All right, if we plug in -2 now, if we plug in -2, it'll make this guy 0, it'll get rid of this guy. It'll also get rid of this guy, this whole thing. So if we plug in -2, that's going to be good. Looks like we'll be able to figure out d. So when x equals -2, what happens? Well, on the left side, you have 4 times -2 squared. On the right side, you plug in -2, makes this 0, it's gone. Plug in -2, makes this 0, it's gone. Plug in -2 over here, you're left with d times -2 squared plus 4 times -2 minus 2. You're left with 16 equals, let's see, 8 times -4 is -32. We get d times a -32, which must mean that d is -1/2. Okay, so we got c, we got d. All right, what are some other good numbers to plug in? Well, all right, so I'll look around here. Well, it might be nice to plug in x equals 0. If we plug in x equals 0, it'll get rid of this guy. We'll be left with b. If we plug in x equals 0 over here, we'll be multiplying c by some numbers, but we already have c, so we can actually fill in for c. If we plug in 0 over here, we'll have some numbers times d, and we already know d. So it looks like plugging in x equals 0 might be helpful. So when x equals 0, on the left side, we are getting 4 times 0 squared, which is 0. On the right side, we're getting a times 0, which is 0. So we're getting 0 plus b times 0 minus 2 times 0 plus 2. c, we know c. c is 1/2. We plug in 0. We get 0 squared plus 4 times 0 plus 2. d, we know d. d is -1/2. We'll have 0 squared plus 4 times 0 minus 2. All right, so what have we got here? We got 0 equals, let's see, -2 times 2 is -4. We got -4b. Over here, 4 times 2 is 8. 8 divided by 2 is 4. Over here, 4 times -2 is -8. -8 times -1/2 is +4. So, all right. We got to solve this equation now. So that's 8. Subtract 8 from both sides. Solve for b. B is going to be 2. Hey, we got b now. All right, well, let's see. We got b, we got c, we got d. We still need a. Well, we can just plug in whatever number we want now to find a. Doesn't really matter. We should choose a nice number. How about 1? That'll make life easy. So when x equals 1, well, what's going to happen? Okay, so we plug into here. We have 4 times 1 squared equals a times 1 plus b. Wait a minute, we know b. b is 2. I believe, yes. And then we have times 1 minus 2. 1 plus 2. Over here we have c. Wait a minute, we know c. c is 1/2. 1/2 times 1 squared plus 4 times 1 plus 2. Then we have d. d was negative 1/2 times 1 squared plus 4 times 1 minus 2. All right, so on the left here we got 4 equals, let's see, we got a plus 2, and then it's being multiplied by negative 1 times 3 is negative 3. We got negative 3a minus 6. Looks right. Okay. Over here, we got 5 times 3 is 15. We got 15 halves. Over here, we have 5 times negative 1 is negative 5. Negative 5, yes, 5 times negative 1 is negative 5, times negative 1/2 is positive 5 halves. Okay, 15 halves plus 5 halves is 20 halves. 20 halves is 10. So we got 4 equals negative 3a minus 6 plus 10. Okay, negative 6 plus 10 is 4. Subtract 4 as you get 0. We'll figure out a equals 0. Yay, so we got a.